Hello, everyone. Um, I'm just going to briefly talk about one medication here that I guess um, is pretty interesting. Um, my name is Snehal Desai, and I'm going to talk a little bit about this one medication here um, on a drug that was recently approved by FDA. It's called Navepegritide, and it's a very interesting drug. And you could see in the diagram it has something to do with um, genetics or genes. The gene mutations. So you could see here like a little figure of a DNA molecule, and you could probably see the little structures there. So this medication is pretty interesting because its use is mainly dealing with children who are 2 years and older with acro or achondroplasia and open growth plates. And what that is when there's a newborn and they have a point mutation within the DNA that they get from their parents as a newborn. It's basically going to kind of suppress the functioning of I guess the structure of you know growth. So like bone growth, for example, or in like medically speaking, like more like chondrocytes or cartilage formation gets slowed down in this case because of a point mutation. But what this medication is mainly intended to do is to prevent the slowdown that abnormally uh, that is not um, this excessive slowdown of that bone growth. So um, this medication is a once weekly subcutaneous injection, and I'm going to show you how this medication works by its mechanism. So as I mentioned, it's a common skeletal dysplasia, and one of the genes that's mutated is the FGFR3 gene, um, which I'm going to talk about in this figure here. So you can see how a newborn has that mutation of a G30R mutation. It's a point mutation that occurs, when there is um, a nucleotide that's kind of like switched, or a when there is some kind of mutation there, point mutation within the DNA. Um, and so what happens here is this newborn is not able to get the normal bone growth. They're actually more shrunk. A lot of things are happening here. So how that happens is typically whenever we look at the chondrocytes or of the growth plate that's between like the ends of the bone and like in the body of it. So you could see here, uh, I drew a little figure here to kind of show you a little bit about it. But technically, what happens is one of those chondrocytes has one of these FGFR3 receptor, and it's located extracellularly, transmembrane, and intracellularly. Whenever normally the FGF or the fibroblast growth factor binds to this receptor, and then it would send some sort of reaction within the um, mechanism to cause the slowdown the cartilage growth. Normally, there's supposed to be some slowdown whenever this is bound to it. However, whenever there is a so without mutation, this would normally happen. But if there is a mutation, then you would see um, this binding may or may not occur, where the FGFs may or may not bind to that receptor, and then it would still cause the excessive slowdown in cartilage growth. So, what this medication does is pretty much kind of just stops that from doing this, so it kind of slows it down by inhibiting the MAPK um, pathway that leads to a slowdown in cartilage growth. Um, so this receptor, which is the NPR2, is actually another interesting receptor because that receptor is actually used for cartilage growth to um, not slow it down or stop it or suppress it. It's actually to allow it. Um, both of these receptors basically are in the same area of, the chondrocytes, and then, they would kind of work in balancing ways, but this medication will essentially kind of help it from slowing down that cartilage growth more. So, um, this I thought it was very interesting, so I just wanted to share it with you all. Just a little bit on one of the new medications that was just recently approved, and if you have any other questions, please let me know. Um, and thank you for watching.